Now we do a simple plot here. Okay, not so simple, right? But the figure on the left here shows the concentration of the two most common greenhouse gas, the red representing the CO2, right? Today, green, right, is the methane gas. So you see, this is today, okay, 0, then this is 800,000 years ago. Now these are measured from the ice core on the previous slide, and the data reveals that the change of these gases over the past 800,000 years. Then you see that today we see a spike. Look at that. Look at the value. Okay, look even the scale. So you see the green graph here works on this scale. I don't compare. I was saying that it's lower than CO2. When we start 800,000 years ago, CO2 was at the level sub 200 ppm V. Methane a bit below 400. Okay, look at today. 1840 ppbV, CO2 400 ppmV, parts per billion, parts per million. Different unit. Be very careful. But I would like you to see, it's not a trick. I want to see the change, relative change, right, on its own. The black line here, this, right, measures the mean surface temperature of the Earth. Okay, fluctuations. -8, 0, plateau, plateau, plateau. Okay, here. And what do we see here? We want to look at this and analyze. There's a strong correlation between the fluctuation of CO2 and the methane gas with the rise and fall of the mean surface temperature of the Earth. You see here? When both CO2 and CH4 peaks and then the temperature spikes. You see? You see a similar trend? Right. So let's triangulate. What it means to say is that these are the facts. This is what you tell the climate change dissidents who don't believe in it. These are the facts we measure. Right. You look at it. What does it mean? How do we get more CO2 and CH4? Human activity. Is it caused by anthropogenic activity? You tell me. Okay. So, with data like this across the same time frame, you can tell correlations. Of course, my caveat is correlation doesn't mean causation. Okay, that's important, but give me some reason. Okay. Now, if the atmosphere holds more water vapor, which is also a greenhouse gas because it traps heat, right? It means that the more moisture-laden air will be able to move over land or converge into a storm systems and produce more intense precipitation. So that's an effect of global warming, the climate change, right? You have more drastic precipitations, right? Flooding, rising sea level here, like very inclement weather, unpredictable. Flooding in Singapore, Tampines. Ooh, great drainage system. How can that be? Never seen it 10 years ago, 20 years ago. Started to see more often. And then we get used to it, see more often. Orchard Road was flooded. We solved the problem. Then we see some other neighborhoods get flooded. Big problem. Canals get flooded. Erosion near Clementi. So some consequences of this heavy precipitation includes the soil erosion, increase of risk of this flooding, excess precipitation, right? There's runoff there. We can also, impair water quality because we have mixing of the different pipes, right? Pollutants, wash, crop damages if you have some agricultural activity, deposited on the soil land, wash away to the water body, okay? Lakes, reservoir, okay? This is not good. Now, here we will really feel the effects of the global warming. Here you see so many recent articles here. China News Asia reports climate change is driving 2022 extreme heat and flooding. This is not Singapore, of course, but again, this is a global phenomenon. We experience different types of observations. that's never happened before around the world because of climate change, right? And it's linked to flooding in Bangladesh, China, heat wave in Pakistan, India, most of Europe, and there's possible correlation between the dry land in the East Africa, and climate change. Okay, in the Tigray region, they're fighting war. Ethiopia, yeah. And you may think that Singapore is very sheltered. Yes, we are. We are very fortunate, but we are not immune to it. We are not immune to the effect. We talk about how we experience flooding. Okay. Now, we'd like you to focus the figure on the left here, right? And this is just taken from the website. We do some citations verbatim. Singapore's continuous temperature record since the year 1948 before independence shows that the island has warmed, and notably warmed more in the mid-1970s when there's rapid urbanizations, in Singapore. And the mean surface air temperature has risen by an average of 0.25 degrees Celsius per decade between 1948 and today. Okay, here, see. Right, 26 point something over here today. So this upward trend is approximately double the trend in global temperature, right? The rate of doubling of increasing temperature, which the global temperature change is about 0.12 degrees Celsius per decade from 1951 to 1921. So IPCC, again, biggest takeaway from this class, know what does IPCC stand for? The Intergovernmental Panel on Climate Change. Okay, it's a report. And in the 2013, the fifth assessment report, it states, it is extremely likely that the more than half of the observed global trend is caused by anthropogenic or human activity that increase the greenhouse gas concentration and other anthropogenic forcings. So the high trend over Singapore might be due to urbanization, human activity, and could also be influenced by the regional variations, right? The man-made global warming effect. Now, 8 of the 10 warmest years on record in Singapore have occurred in the 21st century. Okay, recently, and all 10 warmest years are, since 1997. So you tell me, look at the data of Singapore here: population growth, urbanization, what did we build, and constructions. On the right here, in Singapore, the temperature is expected to continue to rise over the next few years because of global warming. And this article, okay, this is not a commentary, okay? Take note, not opinion, okay? News, journalists, finding facts. This article talk about why temperature in Singapore will continue to be hot, why we are getting warmer, and what we can do to stay cool, not just turning the aircon, not just taking the fan, taking a walk, but what the government can do to mitigate the effects of global warming in Singapore, such that we are exploring the use of novel paint coating to reflect more sunlight, right? Then we absorb them. We can't prevent absorption much, but we can exacerbate the reflections. And the innovation panels, right, that can double up the solar panels. So we can see glass panels here, but through the glass that you can't see, we can embed materials that can act and can turn solar energy into electrical energy. So these solar panels can also be installed to the roof of the buildings because they can be added as insulation, keeping it cool, reducing the use of aircon.